Hey everyone, welcome to my YouTube channel called Duodecimal Division. My name is Eric Larson and today I'm going to share with you why numerals have the shapes that they do. So this is a YouTube channel that's dedicated to exploring the idea of duodecimal math and base 12 geometry. And one of the first things I learned when I started to explore these topics is that our numerals were created by somebody that was using base 12 math. So I'm going to explain to you what that means exactly in a minute. But first, I just want you to, look at all these numerals behind me here on the board and, think about why do they look like that? Why do they all have those specific shapes? And if you're like me, probably never thought about this too much, but when you do, you think, man, they probably just evolved that way over time. Well, what I've learned is that that's not the case. Somebody used some very specific kind of mathematical logic to design these numerals based on geometric patterns. So that's what I'm going to show you in this video. And if you look at the numerals, basically you realize there's two main ingredients to their design: straight lines and circles, or parts of a circle. So that's what I'm going to show you first, is the series of circles that somebody used to create the design of our numerals. Okay, so this is the series of circles that was used to design our numerals. So what is this series of circles? What's the logic behind its design? Well, in order to understand that, you need to know the Pythagorean theorem, a squared plus b squared equals c squared. So I'm just going to write that on the board, first of all. Okay, so a squared plus b squared equals c squared applies to right angle triangles. Okay, so we're going to draw a right angle triangle right here. A and the b are the two sides of the right angle triangle. This side's going to be A, this is our b, and then this side here is c. It's also called the hypotenuse. That's always the longest side of the triangle. So we already know this length is 1. That's the radius of the first circle. The radius is the distance from the center of the circle to its outside edge or circumference. Okay, so the first circle has a radius of 1. So 1 squared plus 1 squared, 1 plus 1 equals 2. So c squared equals 2. So c equals the square root of 2. So we put our compass there and we draw another circle. So as we draw that circle, we come down, we notice that it intersects the x-axis at this point. That's our new a, square root of 2. Square root of 2 squared is 2, plus 1 squared. Again, we're always going to be adding 1, as you can see. So we're adding 1 again. Square root of 2 is 2, plus 1 is 3. C squared becomes 3. C becomes the square root of 3. We draw our new radius to that point. And then we draw another circle. And we just keep repeating that process over and over again. So sometimes when you look on the internet, if you were to research a little bit about square root and rectangles and triangles and whatnot, you're going to see you get this pattern right here, this design. Okay, you can find this diagram quite easily on the internet, and it shows you how to calculate the consecutive lengths of square roots. But often you don't really realize that can also be used to calculate the radius of circles. Series of circles that have consecutive square root radiuses. Okay, so what does all that have to do with the design of numerals? Well, I'm going to show that to you right now. I'm going to start with the symbol that represents the number 2, or the numeral that represents the number 2. Okay, so we're going to use the second circle in the series. And what I'm going to do is I'm going to mark the 4 points where that circle intersects the grid underneath. Those points are actually called lattice points. We're always going to be looking at the lattice points where the circle intersects the grid. You can see that each circle has a relationship with the grid underneath in different points. So they're all unique that way. And what I'm going to do is just basically trace some of those lines. Okay, so I'm going to trace that curve at the top just like that. I'm going to connect these two lines just across a diagonal like this. And then I'm going to draw a line along here at the bottom like that. And there you have it. That's the base of why the numeral 2 looks the way it does. The most important one is to notice that that bottom line has a length of 2. And that's a quality that all the numerals have. They all contain the length of the value of the number that they represent. So that's what we're going to use to kind of go through and see each numeral, how it's designed with that idea in mind, and how it's playing off of the relationship between the circle and the grid underneath. These lattice points are always part of the design. I'm going to show you what all that means now. That's why the numeral 2 looks the way it does. Now I'm going to jump ahead a little bit and do the numeral that represents the number 5.